For our last problem, we have a question about lists. So this question is asking you to complete flattened list, which, given a list of lists of variable length that contain numbers, it should return a list of just those numbers maintaining the same order that they were in. So, for example, if you look at the doc test, this list has a bunch of nested lists. Like, for example, this itself is a list, this is a list, this one as well, and that one as well. And then all together, the output should just be 1 through 9 without any of those nested lists. So just like really clean, like streamlined list that combines all of the sublists. Okay, so immediately we should try to think of iteration or recursion to do something like this. And I'm just going to use iteration for this. But you can do it however you like as long as it functions. And so already we know we're going to build a resulting list. So I'm just going to initialize result to be some empty list. And now I'm going to loop through every item of the list. So you can call it like sublist, something like that. And now we're going to add those elements in that list. So when we look at the sublist, it's going to be, for example, 1, 2, 3. And now we have to peek inside that list and add those elements. So we have to have a loop for that list as well. Okay, then we can say for lm in sublist, result plus equals lm. Okay, so this should be something like you're adding first 1 and then plus 2 and so on and so forth. And just as a note, you can also use dot append 1, or in this case we use the general name lm, and this will work totally fine. And now to finish off this problem, we're going to return result. Okay, so I think perhaps the trickiest part of this problem is that you have to remember when you iterate through the list, you're going to get lists because inside the list are just more lists. So you have to have 2 for loops, one to loop through the list, the outer list. Oops. This outer list, and then another to loop through the inner lists. And that's why we need 2 loops. Okay, so for our last problem of the whole exam, the extra credit. So it says our function so far only works with 2-dimensional lists, meaning 1 level of nesting. And you can go back to the example and say, and see that like there are no lists that are perhaps like if this was 6 and then 7, 8, this would be an example that doesn't work. But we can adapt it to make sure that it does work for any kind of nesting. For example, like we had, oh gosh, I don't know why you do this, but you could literally have something like this, and man, I don't even know how many brackets this is. Something like that, yeah. So we want to have a solution that would work for this. You don't actually have to go and write code for this, but all you had to do was describe in 2 sentences how you would adapt this to handle an infinite level of nesting. So, for example, this monstrous thing. And the short answer to this is just recursion. One of the beautiful things about recursion is that it keeps operating on your subproblems until they reach some point where the subproblem is solved outright. And that's why recursion is so wonderful for this case, because you can have some kind of recursive solution that will keep, stripping away these brackets, like it senses that there's lists and then keeps trying to get like towards the middle of the list, and then finally you will reach some point where you don't have a list, you have a number, and then you can finally add that to your list. Your result list, not this list. Okay, and so how might we do this with recursion? Well, we can actually just write an example function. So for example, if I have a function, let me call it like recursive flat or something like that. Let's say it takes in a list. Okay, so as always, we want to have a base case, and generally with lists, it's pretty common to see a base case where the list is just empty. So if length list equals 0, and because later on I'm going to write code that will add the lists together, like append them to each other, I want to return an empty list. Oops, I meant empty list, because if I add an empty list to a list, it just adds nothing. But if I try to return nothing and add that to a list, it will give me some like error, like you try to add non plus list, and then the computer gets mad at you, and your code like crashes and burns and things like that. So yeah, make sure that if you're ever like adding lists together, that your base case doesn't ruin the code and doesn't error out because you try to add like non to lists or something like that. So yeah, basically know what kind of data that you're working with. So because we're working with lists, that's why we're using an empty list here. Okay, so I'm going to use this handy dandy function that you'll probably use a lot later, or already have, and it's called isInstance. And what this does is basically it takes in some kind of element and checks to see if it's of some type. So I can say list here, and then whatever I put here, it will check to see if it's actually a list or not. And so this is the part where I think about how to break down the step into smaller problems. And a good way to do this with any kind of like list recursion problem is just to take it one element at a time. And the most intuitive thing is to just look at the first element and check that, and then you can recurse upon the rest of the list without the first element. So I'm going to put list of 0 here. So what this is going to do overall is check to see if the first element is a list. And if it is a list, then I want to recurse upon that list. So I'm going to call the same function on it, list of 0, and then I can't forget about the rest of the elements, so I'm also going to recurse on the rest of them. List of 1. Okay. Now, let's say the first element is not a list. Well, that means it should be an element. And if it's an element, we can add it to our list right away. So you can have an else statement here that says return, we want to return list of 0 wrapped in a list plus recursive flat list of 1. Okay, so I just wrote a ton of code, and maybe it didn't make sense throughout the journey of why I was doing it, but to make it all cohesive again, I'm going to actually run through an example. So let's say we have an example of 1, 2, 3, and then maybe 4, 5, 6, and hopefully I did my brackets right. Okay, so let's try to follow our code with this example. So we come to the base case. Of course, the list is most definitely not of length 0, so we don't go into that case. And then we check to see if the first element is a list. It is not a list, so we go into this case at the bottom, and we're going to add list of 0, so 1 plus, I'll just say RF to be short, the rest of the list, so it's 2, 3, 4, 5, 6, and one more bracket. There we go. Okay, now we have to evaluate this thing, and I'll just skip my base case because we know for sure that's not true. And we notice that the first element of the list is actually a list. So we're going to go into this case over there. Let me erase this. And then this is going to evaluate to RF of 2, 3 plus RF of 4, 5, 6. And now we gotta evaluate both of those. So let's start with this one. RF of 2, 3. Well, we can see that the first element is going to be an actual element, not a list. So we're in this case now, not that one. So we're going to add 2, and then plus RF of just 3. And we know this should evaluate to 3, because the first element is a number, and then RF. Oh yes, so since the first element of the list is a number, we're going to be in this case, this third case, again, and then we're going to say RF of list of 1 blah blah blah. But because this list only has one element, list of 1 is just going to be an empty list. Alright, and we know this is just adding an empty list. Okay, so far we have 1 plus 2 plus 3 all in list, and we can do the exact same work for this, and it should be very similar. So this is going to be 4 plus RF of 5, 6. And I'm kind of skipping the steps I was doing earlier because I don't want to get too repetitive. But remember, I'm still just like walking through the calls and checking each case. And because I remember these cases, I know like which one is going to apply. For example, in this one, we know that the first element is a number, so we're actually just going to add it. And then we're going to recurse upon the rest. So then this is going to be 5 plus RF of 6. And then we know this is going to be just 6 plus RF of empty list. And we know this is empty list. So all together, when we add all of this up, it's just going to be 1, 2, 3, 4, 5, 6. And you can try to follow along the additions here, 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 and here, 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 here. Okay, so that is recursive flattened list, and that is the last problem of fall